Hello everyone, good morning. Uh, okay, so we will continue to talk about the cost function. Okay, so in the last class we learned what average cost is. It's simple. It's a cost per unit of output. You can calculate by dividing the total cost by the quantity of output. So that's average cost. Okay. So from this graph, this is total cost here when you produce T1. So divide the total cost by T1 at this point, then this is the average cost. Okay, so if you define these slopes, if you define this line here, the line that connects the origin and then the point on the cost function, then the slope of this line is the average cost at T1. We can calculate the average cost at T2 by drawing a line that connects T2, the height and that T2. Then you can calculate the slope of this line at T2. Then this is the average cost at T2. Okay. How about the marginal cost? Marginal cost is the increase in the total cost when you increase the output by 1 unit. So this is extra cost caused by increasing the output by 1 unit. So cost goes up by $6 when you increase the output by 2 units. The marginal cost is the increase in the cost divided by the increase in the output, so that the marginal cost is $3. Okay, the slope of this total cost curve, which is the increase in the cost with respect to the increase in the output, that's the slope of this cost curve itself. So that's the marginal cost. Okay. So can you draw average cost and marginal cost curve when the total cost curve is this shape? You can do that, but let's do it together. Okay, this way here. So, first thing that we can see here is that, as you can see, marginal cost. Let's first look at the marginal cost. Marginal cost, as you can see, initially like this, slope. Slope is diminishing or increasing. Slope is diminishing like this. Slope, 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 slope. Slope is diminishing until this part. However, after this part, slope is increasing. So marginal cost is initially declining, but after some point, after this point here, after this particular point here, or around this point, marginal cost is increasing. Okay, so marginal cost curve can be drawn like this. Initially, it's decreasing, but after this point, it's increasing. That's marginal cost. How about the average cost? Average cost is also, so let's first look at, let's connect this line. So so let's first look at this point here. We draw this straight line, and then the slope of this straight line at this point is the average cost. Average cost curve is also declining until this point. Why? Because as you can see, look at these lines here. This, okay. Let's look at this line here. Okay, relative to this one, it's flatter. Relative to this one, it's flatter here. Okay, so as t is larger, average cost is declining. Okay, so average cost is also declining. But the minimum point is here, right? Minimum point is here. Because after this point here, after this point, actually, average cost is actually increasing. As you can see, it's flatter here, but it's increasing here. After this point, average cost is increasing because the line is actually increasing here. The slope of this line is actually increasing. So that's why this is the minimum point to where the average cost is reaches its minimum. After this point, the average cost is again increasing. Before T star, marginal cost is larger or average cost is larger? Marginal cost at this point is slope. Average marginal cost is the slope of this cost curve, which is flatter than this line. Okay. Again, marginal cost is flatter here compared to this average cost, right? So that's why before T star, marginal cost is less, okay? But after T star, as you can see, marginal cost is larger. Marginal cost is larger. Marginal cost is larger because it's steeper than this line. So marginal cost is larger after T star. So given this, you can draw the average cost curve in this way. So T star, let's first pick T star here. T star, this is T star. Okay, this is T star. This is T star. And then before T star, marginal cost is less. Okay. But at T star, marginal cost intersects the average cost. So that you can draw like this. Okay, so that's average cost. Okay, so that's marginal cost. Then that is average cost. Okay. So before T star, marginal cost is smaller. Okay. However, after T star, at T star, but these curves intersect, and after T star, marginal cost is larger than average cost. Okay, so that's the average cost curve and marginal cost curve. Okay, so one thing that we can see from this situation is that average cost curve declines with T and when average cost is greater than MC. Let's look at this graph here. Okay, average cost declines with T. Average cost declines with T. Average cost, because this is a minimum point where average cost is minimum, which is T star. Average cost is declining. Under what situation? When average cost is larger than MC. Average cost is above its MC. So when average cost is above its MC, average cost is declines with T. Which means that when marginal cost is larger than AC, then average cost curve is increasing. Okay. So this result can be derived using this mathematical result, which you can see, and then try to write down what we're doing, and then you can understand what it is. But rather than this derivation, try to remember this result. Average cost is declining when average cost is larger than MC, and average cost is going up when marginal cost is actually larger than AC. It makes sense because when marginal cost is less than average cost, then that drives the average cost down. Okay. When marginal cost is larger than AC, the larger marginal cost actually drives average cost is up. Okay. So that's why we have this result. Okay. So we just reviewed these fundamental concepts that probably you learned from Econ 101. Now we can go to, why do we study these fundamental concepts? Because these concepts will be used to understand the transportation industry, which we will discuss in the next week. Okay. So the last fundamental concept that we will study today is returns to scale. Returns to scale tell us how the firm's productivity or cost efficiency depends on firm's alpha size. Okay, so there are three kinds of returns to scale. There are depending on the firm's production function and depending on the firm's cost function. Okay, there are three kinds. First, increasing returns scale. The firm is more productive as its output size is larger. Then we say that it has increasing returns to scale. Decreasing returns to scale. The firm is less productive or less cost efficient as the firm's output size is larger. Then we say that there are decreasing returns to scale. The firm's productivity or firm's cost efficiency does not depend on the firm's output size. Then there is a constant productivity, constant cost efficiency. Then we say that there are constant returns to scale. The returns to scale can be formally defined from either production function or from the cost function. But let's look at the production function to define a returns to scale. Okay, increasing returns to scale. Okay, we say that the firm's production function exhibits increasing returns to scale when this production function satisfies this condition. Okay, so alpha. So remember, T is the output level, output quantity that's produced by employing L units of labor input, and K units of capital. Okay, so when alpha is a number that is larger than 1, and if the production function satisfies this inequality, then we say that we have increasing returns to scale. Okay, it is also called economies of scale. Increasing returns to scale is also called an economies of scale. What's the intuition behind increasing returns to scale? Because it should hold for all any constant number that's greater than 1. Let's just use alpha of 2 to appreciate its meaning. Okay, just by plugging a alpha of 2, we can understand what this expression means and what this expression means. By plugging alpha of 2, let's first look at this original production function, which is the original output produced by employing L units of input and K units of capital. Okay. Then what's the meaning of this T of 2L and 2K? That's the output level produced when we double both of the inputs. Okay. When we double labor input, when we hire twice of the original labor, when we hire twice of capital, then it gives the output level obtained by doubling these inputs. What about 2 multiplied by this output? That is simply the double of the original output. Okay. IRTS, increasing returns to scale. Increasing returns to scale means that the left-hand side is larger than the right-hand side. Okay. So this is larger than this one, which means that when you double both inputs, when you double both inputs, you produce more than the double of the original output. Okay, so let's say you increase the factory size by you increase your factory's size by employing twice of more labor inputs and twice of more capital inputs. By increasing your factory size by twice, then you can produce more than twice of the original output. So there is actually increasing returns to increasing scale. So that's why it is called the increasing returns to scale. By doubling your scale of your production, you can be more productive. Okay, so that's why it is called IRTS. Okay, so there are 2 possible organizations of production for the firm. So more intuition behind IRTS. Consider a firm and assume that the firm's production function exhibits IRTS. So now the firm is going to employ double of the original inputs by employing double of the labor and double of the capital. Okay, you are going to employ those doubled inputs in one single factory. Okay, single factory. Then you can produce that amount. This is the rectangular measures the quantity of output produced by this single factory. So it's a large rectangular. The other option is to have two separate factories with L and K employed in each factory. So again, rectangular measures the quantity of output produced by each factory. IRTS means that when you set up a large factory where doubled labor and doubled capital are employed at the same time in one factory, then you can produce more than the twice of these separate factories. So in that way, you can be more productive and then you can produce more by setting up this large factory. So that's why there is an increasing returns to scale. Okay, okay, it makes sense to define in this way. Okay. How about decreasing returns to scale? We say production function exhibits decreasing return to scale when this inequality is reversed. Okay, DRTS, decreasing returns to scale, is also called diseconomies of scale. Okay. Also, in the same way as we did for IRTS, let's do it for DRTS. So by doubling inputs, you produce less. Now you produce less than the amount that you could produce by operating two separate factories. Okay. So consider two types of production organization as we did for IRTS. Now let's do it for DRTS. One unified factory with 2L employed and 2K employed as inputs. The rectangular measures here measures the quantity of output by employing twice of labor and twice of capital. Okay, then the factory in each factory. Okay, the separate factories. So you produce less in the unified in a single factory with employee of these doubled inputs. You produce less than two separate factories. So that's why there is decreasing returns to increasing your factory scale. Okay, scale. So that's why we say there are decreasing return scale when you become less productive when you increasing your factory size. So finally, constant returns to scale. We say production function exhibits constant returns to scale if the output level produced by increasing your factory size by employing more of these inputs is constant to and the same as the original output multiplied by this factor that determines the size of this factory. So production organization does not matter for productivity, whether it's a larger production or separate production with each being small. That does not matter for productivity. Okay, so that's constant returns scale. Okay, so now we can define the returns to scale from production function. So we defined, so far we have defined the returns to scale from the production function. Now we can define it from the cost function. So cost function exhibits increasing return scale if average cost declines with t, the output size, then we say that the cost function exhibits increasing return scale. The firm becomes more cost efficient in the sense that the average cost is going down as the firm's output size is larger, then there is increasing return scale. There are returns to scale. There are returns to scale in terms of its cost efficiency by increasing its scale. Then we say that this is increasing returns to scale. Why is it increasing return scale? IRTS, including return scale, means that the firm produces more than the double the output when it doubles its inputs. It means that the same time it means that to double the output we need less than the doubled input because it produces more than the doubled output when it doubles the inputs. So in other words, it becomes more productive as we increase their inputs. It means that to double the original output, we need less than the double of the original inputs. Okay, so we to double the output, the denominator, when the output is doubled, we need less than the double of the input, L and K. So that's why when the denominator goes up by double, the numerator does not go up by not less than by double. So that's why this average cost is diminishing, because when the denominator goes up by double, the numerator goes up by less than double. So that's why average cost is going down as t is larger. Okay, does it make sense? So record that. Okay, so in this way, okay, AC goes down as t is larger, then we say that this is IRTS. Okay, so also AC goes down as t is larger. The same thing as saying that AC is larger than MC. Where did I see? We saw this property from this one here, from this mathematical result. As AC declines with t, average cost declines with t when AC is larger than MC. That's what we looked at from this slide. Okay, so it's the same thing. So okay, so AC goes down as t is larger, which is the same thing as that. AC is larger than MC. So we can say that. So based on these two, we can say that we have IRTS cost function. We have IRTS cost function when average cost is larger than MC. Okay, let's look at this example here. Can you see that average cost curve? So look, this is the cost function with the intercept of 100. So the intercept is 100 and the slope is 2. So t is going up by 2. The marginal cost is actually 2 because the slope is constant at 2. But as you can see, average cost is the slope of this connecting line here, which is actually larger than marginal cost. So for this particular case, average cost is always larger than marginal cost. Also, average cost is always diminishing with t. So in this way, we can say that this is the example of IRTS cost function. Whenever we have this cost function with a positive intercept and constant slope, we have IRTS cost function. Okay. So IRTS is the case where average cost is going down. Now what about DRTS? If average cost is going up, then we have DRTS cost function, diminishing returns scale. The example of DRTS is this blue cost function, which is convex shape. As you can see, marginal cost is always larger than average cost. Average cost is the slope of this connecting line, whereas the marginal cost is the slope of the cost curve itself. As you can see, marginal cost is always larger than AC. So we have marginal cost that's larger than AC. So we have the DRTS cost function for this particular case. Okay. Finally, so whenever we have a larger average cost than marginal cost, we have IRTS. We have larger marginal cost than average cost, we have DRTS. When AC is going up, we have DRTS. When AC is going down, we have IRTS. Finally, if average cost is same regardless of T, we have CRTS. In this case, average cost is same as marginal cost. This is an example of CRTS. Cost curve is linearly a straight line that's linearly increasing. Then we have constant average cost and constant marginal cost. So we have CRTS cost function for this particular case. Okay, so that's it for today. Thank you for listening, and then see you next week.